Okay, as I promised 2 weeks ago, I'm going to explain you in a little more detailed way how you should configure triple SD to achieve best uniqueness of your UIs and gates allocation. So a quick reminder from the slide from the last vlog about triple SD. When you're using algorithmic mapping from a few domains into Unix space of UITs, let's focus on UITs. It works the same way for the group identifiers. When you try to map the security identifier to Unix identifier to UID, you simply get the relative identifier part of the SID, then the so-called first RID, so the first in the range RID is used to construct a slice name, and then the slice name is used to calculate a UID range to be used on the Unix side. And this is done with Marmor hash algorithm and modulo of number of ranges you can allocate on the Unix side. Um, of course, it's nice algorithm for the first try, but there's no guarantee that when you try to allocate a UID for a user from the same domain but from a different range, or from the user from a different domain, or from users from multiple ranges, you will not end up with the same UID as it's done here. So in this case, SSSD of course will not reuse the UID in the same range, but it will just try to use next range. And because of this, the allocation of UIDs depends on the sequence of calls. So, for the first call, you simply get this result, and for the next calls, it may be that you have this number plus n, or plus 1, or plus 2, or plus n even. Okay. So what are the main parameters governing this process? SSSD has a few of them. It's of course a definition of the minimal Unix attribute like UID that can be used by SSSD for mapping. Of course, there's also the upper boundary like maximal attribute to be used. And then the range size, which, as you know from the previous VLAC, is the definition of the range used on both sides, AD, security identifiers, and Unix attributes. And then there's so-called default domain, which can be used to guarantee that the primary slice of this domain will be allocated as a first range in our Unix identifiers. So for this range, for the primary slice of one of the domains, you can have this guarantee. And then there's quite new parameter telling you how many times you can use the secondary slice. If you don't know what secondary slice, I will explain in next slide, so don't bother about it. Okay, how to configure it properly? It's a really difficult question. So what I did is simply I developed a simulator that can help you to show the probability of collisions. You can find it on GitHub, and when you have your domain identifiers, when you have your ranges, the minimal and maximal relative identifiers of your Active Directory domains, you can simply use this simulator to check, what are the consequences of specific numbers. Of course, you think that if the range on the Unix side is smaller than the range on the AD side, then you will have collisions. But surprisingly, what you will see shortly in this vlog is even if you have more UIDs to be allocated on the Unix side, it normally means that you will end up with collisions. Okay, so let's define a few words I'll use in the following slides, or live demo of this vlog. So let's think that we have those four users coming from four different ranges, but for those two first users, like blue and this light green, you have the same primary range. So the calculation of Marmor hash modulo number of ranges gives you number 1. And then for this user, it gives you number 2, and for this gives us number 3. So I will call the primary range for the UID and GID the range that is just coming from this calculation. And then if this is not the case and we have to allocate next, use this the part allocating the next range, I will call it, following the triple SD code, I will call it secondary slice. I'm also using kind of order of secondary slice. So if there's a first order secondary slice, then it means that this is just right after the slice that should be allocated. So if we have a primary range number 1 and we will allocate for this item the range number 2, I will call it first order secondary slice, and then if this is allocated 2 slices after the primary one, I will call it secondary order, and so on. Okay, so let's think about it and check what may happen just when we allocate user identifiers in different order. So let's say for the first case we have a primary range 1 allocated. The user from primary range is getting a UID. Okay, it's allocated. It was not used. We can allocate it. Then we are trying to allocate a UID for a guy from the range 3. Yeah, not used. We can just use it. Then we're trying to allocate something from the range 2. Yeah, it's also allocated. And then we're coming up, it's also allocated in the primary range. And then we have the user whose primary range is 1. But 1 is not empty. Second is also used. Third is also used. And we have allocated range number 4 to this user. So this means that this user gets third order secondary range. Okay, let's check different case. We can have primary range 3, so the user from primary range 3 gets the range 3 allocated because it was empty. Okay, then we have a call for the user from the primary range 1 and also gets primary range 1. And then we may have, call for the user to allocate the range number 1. And yeah, 1 was allocated, so we're trying next slice. Next slice is not used, so we can allocate it. And it sounds quite nice, but when we have a call to get the name or unique identifier, UID for the guy from the range number 2 or the one who should normally get the range 2, then it will go to range 4. Just because 2 was allocated, 3 was allocated, and it tries to allocate range 4 for this user. It's just next and only one in this case available. Okay, check different scenario. We have also the call for the user from primary 1. Okay, it's allocated. Then we have a call for the user from the range 2. Yeah, it gets allocation. Then we have a call for the user from the range 1. It gets allocation, but in the range 3. And then we have a call for the user from the range 3. And it also gets allocated, but it's first order secondary, and this is a mistake. It's really second order. Okay, so when you will go to the page I just mentioned, this my GitHub account, and to the SSSD ID map simulator, you will find a code that can really help you designing the parameters you will use. Currently, the parameters are hard-coded there, so yeah, this means the LWD map range minimum, range maximum, and then we have a range size, but really there is a loop over range. Over range is this kind of main loop for this simulator, and then you define your Active Directory domains. You just have to provide domain IDs. So this is the part of a security identifier that comes directly from the domain. So this standard part like S1 521 is added, and then there's a relative identifier which is selected randomly. By default, as you see, it just makes 8,000 calls. So if you have really a lot of users, the ranges of reads are much larger than mine. It's just a training. In this default, this is just a training. So then you have to adjust those parameters. Okay, and what will be the result? So yeah, let's call it. I have the simulator here. When you will start the simulator, you will see that it will tell you how many ranges it can allocate with the range size of your selection, and then it will randomly pick up one of the domains that are configured. That will also pick up random relative identifier from the configured range, and it will try to allocate the Unix identifier, UID, GID, whatever. Okay, in this case it will be 8. Nothing was allocated, so we get 8. 8 is allocated. And then if you check next calls, you will see that at some point you will get some collisions. Okay, we have some collision here. Yeah. So it tried to allocate slice number 8, but this one was already used. And in this case, if 8 is already used, we just have to look for another slice. Yeah. Oh, sorry, it was here. So we tried to allocate 6, but 6 was on the least, so we tried to allocate next. And it ended up with allocating of 7. So this is first order secondary slice. Okay. So at the end, you will have a plot showing you how many tries, how many ranges were available with this range size. This is the green bar, and here is scale. And then we have a column showing you how many first order, in this case, because we only had first order secondaries used in the test case here. What is the probability of simply getting a collision of the first order? Okay, I have a few examples for more complicated scenarios where you can be really interested in. So let's check the situation. Like here we had a 3 domains. We checked, what is the probability to get first order, second order collisions, and we started the simulator a few times, getting different results. So this is the first result showing the probability is like 60% to get a collision of the first order. And there's a small probability of second order collision. In exactly the same configuration, you may get much higher number for second order, but you see that the first order is lower. It's just because this is so random, and as you've seen on the presentation, having different order of the first calls changes the collision probability a lot. And then another result. Of course, those are not very meaningful. It's still just to increase your understanding of how SSSD algorithm mapping works. But really what you're interested in is executing the simulator over a loop with different range sizes to check, the probability of collision for your particular case with your maximal and minimal relative identifiers on Active Directory side with a specific set of Unix identifiers, because it is very easy to understand. Larger the portion of the Unix identifiers you can use, the better results are on your side, so the collision probability is lower. But as you see, even here, we see that there's some kind of magic number, and this magic number just comes from the specific domain identifiers that were used. And you cannot know what is your magic number without the simulator. So this is why you should really check this. And of course, it's very important to check also the raw results, because it may happen that some results were not displayed on the plot. The plot will only contain up to 4th level of allocation of secondary order allocations. And then if we have like only a few allocations but very high order, it may mean that the collision probability is very high, because high order of secondary slice allocated means that really this slice could have had a conflict with multiple ranges on AD side. Okay? Yeah. I feel like this is a fast explanation of how algorithmic mapping on SSSD works. I know it's not very easy. I hope that you will ask some questions if you have them. Thank you for watching.